Hey guys, Mr. Yisley here. So we're on to lesson number 18 in chapter 4 about writing linear functions. And in lesson number 18, we're going to talk specifically about using a line of fit. And so if you remember back from your vocabulary section prior to the lesson, a couple of lessons, you should remember that a line of fit is a line drawn on a scatter plot that is close to most of the data points. So it's kind of saying, hey, here's the trend that is going on, right? It's not going to necessarily go directly through every point on the scatter plot. It may go through a few of them. It may be really close to all of them, or should be really close to all of them, but it's just basically a line showing, hey, this is what typically happens with this data. It's kind of like how I highlighted those correlations. Those were kind of like highlighting a line of fit. Here is what is taking place. And so we're going to talk about in lesson number 18 how to use a line of fit, kind of the process of it. And then in lesson number 19, we'll do an example and show this in motion. So when it comes to using a line of fit, all right, and we're talking about specifically to model this data, the first thing we want to do is, or that we have to do, is we have to make a scatter plot of the data. All right, so we've got to make a scatter plot of the data. So we learned how to do that in lesson 17, all right? Sometimes they'll even give it to you, the scatter plot already, all right? But you need to make that scatter plot. And typically our scatter plots, as we talked about, are quadrant 1 graphs, so make sure that you're using an appropriate graph when you do that. The second thing we want to do is, after we've plotted this, is we want to determine, is there a correlation, right? Does it have a positive or negative correlation? Does it have no correlation? Like, is there a relationship between the two pieces of data that we have, right? Or the two pieces of information that create the data we have. The next thing we want to do is we want to draw a line that appears to fit the data closely. And for this, we need to have a ruler for this. So make sure that when you do this, right, you use a ruler, because we need that line to be as straight as possible. Right? One thing I want you to keep in mind, all right, is when you draw this line, there should be a similar amount of points above and below. So I shouldn't have like 10 points above and only 1 point below it, all right? I could have 3 points above it, the line, and 2 points below. Those are similar numbers. Obviously, it's best if we have numbers that are equal on both sides. You may even have your line go through 1 or 2 points, right? That doesn't necessarily have to be the same as the amount of points below or above, all right? It just needs to be similar. We can't have a lot of them above and none below, or a very little amount above but a whole lot below. It needs to kind of go directly through the middle of that data. So make sure similar amounts of points above and below when you draw your line. And then the last thing we want to do after we've done that is we're going to write the equation of the line. All right, we're going to write the equation of the line. And you're going, oh no, writing an equation of a line that I don't really know, like, you'll be okay, right? Because we've actually learned all of this information and what we need. So what we need to do in that instance is we need to find 2 points that are on that line. So it's always a good idea to try to get your line to go through 2 points, directly through them. So we're going to use 2 points to find the slope. Now, if for some reason your line doesn't go directly through 2 points, typically what you might want to do is use 1 point above the line and 1 point below. But if, as all possible, in 99% of situations, let's get that line going through 2 points. All right, so we're going to use those 2 points to find the slope. All right, and in order to do that, we then need to use slope formula, which, reminder, slope formula is m equals y2 minus y1 over x2 minus x1. Right, that's our slope formula, and we use that to find the slope. Right. Then once we've found the slope, then we can use the point slope form, because we know a point on the line, right? We know the slope of that line then. So then we can go in and use the point slope form, because we have a point and we have a slope. And the point slope form says, hey, put it into y minus y1 equals m, which is the slope, times x minus x1. Remember, x1 and y1 is where you put the point, all right, the x and y coordinates, And then from there, we've learned how to simplify that down into the slope-intercept form. So we would distribute the m to everything inside, then we would add or subtract this y1 across to get the y by itself. So we've learned all of that information of that fourth part already in previous lessons. But we will model that here in lesson number 19. So again, this is kind of the four things that we have to go through. First, get your scatter plot. If they didn't give it to you, plot it and get that data on a graph. Second, decide if there's a correlation. Is there a positive or negative correlation? That's always a help. All right. Then draw a line that appears to fit the data closely. Let's try to get it through 2 points directly, but let's make sure there's similar amount of points on both the top and the bottom, or above or below the line, I should say. All right. And then fourth, go ahead and write that equation. Use the 2 points that you drew through, or one above and one below that are really similar. All right. To find the slope using the slope formula. Then take that information as well as the point that you went through, right, and plug that into point slope form and simplify it down. All right, well, if you have any additional questions on this process, please let me know. But otherwise, continue on and see this example put into motion.